OSPF basic configuration. In this video, I am going to talk about the basic configuration of the Open Shortest Path First or OSPF in two methods. Okay, after that, we can talk about more advanced features related to the OSPF. The first thing that we should talk about that is the configuration of the OSPF. Also, we will learn about the verification of OSPF different features. First, let me to say that we can configure OSPF version 2, okay, OSPF for IPv4 with two methods. The first method is using the OSPF network statement, and this is the traditional method. In most cases, we are configuring this method, okay? And also we have another method of configuration. The next method of configuration of OSPF or basic OSPF configuration is the interface specific configuration, okay? You can configure all of one network, okay, with the first method or with the second method or with the combination of these two methods. First, let me to talk about the OSPF network statement method. The configuration of the OSPF network statement is, for example, can be done with this command, with the router command, router OSPF, then process ID. Okay, I will talk about the process ID. And then we will go to the router config router. Okay, here you should use the network, then interface IP, okay, interface IP. After that, wildcard mask, and then area ID. You know that in OSPF, we should identify which interface is residing in which area. Because of that, after enabling OSPF on one interface, actually we should identify that interface is working in which area. Okay, this is the first method of configuration of the router OSPF. Let me to show you or talk about the detail of this method. Here in the R1, I'm going to use the OSPF network statement command, okay, or OSPF network statement method for configuring of OSPF on this router. Let me to write here, network means we are configuring this router with the network statement. Okay, first we should understand the process ID. You know that in OSPF, okay, we have one database, and after SPF calculation on that database, we are selecting the best path according to the result of the SPF calculation over the link state database. Okay, and finally we will use best routes, okay, in the routing table. Here assume that we have R1 connected to the R2. In most cases, we are using one OSPF instance between the router 1 and router 2. But it is possible to configuring multiple OSPF instances in one router. For example, assume that here we have router 2 connected to other network. Okay, assume that here we have one company. This is company 1, okay, and this is the company 2. Okay, actually we have two routing domain, and these two routing domain are not, for example, working in each other. This means that we have two exactly separate routing protocol. It is possible that you configure between the router 1 and router 2, for example, OSPF, and between router 2 and router 3 EIGRP. Okay, this means that in each company we can configure different routing protocols, but in some cases you want to configure OSPF in both company, OSPF and also OSPF, but these two OSPF are not working with each other. Okay, actually here in the OSPF between router 1 and router 2, we have one link state database, okay, and also in the other side between the for example, router 2 and router 3, we have another link state database. These two link state database are not same with each other. Each of them are independent from each other. Actually, here we have two independent routing protocol, but both of them are OSPF. This is possible. You know that in this class we will learn about a concept, we call it redistribution. In the redistribution concept, you can import in routes from one routing protocol to another protocol. Okay, we call it the redistribution, and in this class we will learn about the redistribution. For example, you can connect one EIGRP network to one OSPF network, or two OSPF a network to each other. This is possible, but by default, the routes that are to learn from the OSPF2, means OSPF process 2, does not propagate to the OSPF, for example, process 1. Actually, in the router 2, we have two independent protocol. When you are configuring in the router 2, for example, OSPF and EIGRP, you can configure on router 2, router OSPF, and then router EIGRP, you know it, okay? But when we have two OSPF instance, we cannot use router OSPF again, router OSPF. They overwrite each other. Because of that, you need to configure in one router OSPF 1, okay? Means the process 1, and also router OSPF 2, means the process 2. Okay, with this process ID, we can identify two processes from each other. For example, when R1 sending its link state to the process 1, okay, of the OSPF, the R2 doesn't send this link state to the, for example, interfaces member in the process 2. Okay, you will learn more than this about the process ID, but let me to say that we are using process ID to identifying two processes of the OSPF from each other. In most cases, okay, it is recommended that we are using the same process ID in one routing domain. For example, in this routing domain, okay, we can configure OSPF, okay, process ID 3 in the router 1, but OSPF process ID 1 in router 2 for this side, for the left side, and OSPF process 2 in the other side. Okay, it is possible you use same process ID between two routers in one company, or different process ID, because this is a local identifier for identifying, for differentiating between the processes of OSPF. But it is recommended for the consistency that we use the same process ID in the routers of one company. But if you want, you can use different process ID. This is better to configuring the for example, same process ID. As you can see, in the router 2, we should configure two process ID, process 1, process 2, for example. But if you, but it is recommended between routers in one company, we are using the same process ID. But this is not mandatory. Okay, in this class, in most cases, we are using one process in one router. Also, in the, for example, redistribution part of this class, you will learn more than one process ID. Okay, this is the story of the process ID. For example, in this scenario, we have one routing domain. Actually, we have two areas, but all of these areas, okay, are areas of one OSPF instance. What does it mean? It means that, for example, you can use one link state database in the router to include two area 0 and also the area 1. Look at here, this is our routing domain, one OSPF, okay? But inside of the OSPF, we have two area ID. Inside of each OSPF instance, we can have more than one for example, more than one area. That's it. Okay, now let me to talk about the configuration. Here, I'm going to configure the router 1, okay, with the traditional method or with the OSPF network statement method. Router config means R1 config. Here, we should use router OSPF, for example, 1, okay? This is the process ID, local identifier, router config router, okay? Such as the EIGRP, we should use network 10.121 quad 0, means please enable OSPF on this IP address, but here you should identify the area quad 0 or area 0. Actually, with these commands, we have configured the interface serial 10 of the router 1, okay, with OSPF and also in the area 0 in the process 1. Now, interface, okay, serial 10 is working, okay, or is enabled by the OSPF process 1, okay, and also in the area quad 0. That's it. This is the configuration of the router 1, okay. Also, In the router tree, we can configure with different method, the interface specific method. I will show you all of this configuration in another scenario with more configuration. Here we are only practicing, okay? In the router 2, if you want to configure OSPF with interface specific configuration, again, you know that because this is interface specific, we should go only to the interface name, okay? And then router config if. Here you can configure easily IP OSPF, then process ID, okay? After that area ID. So easy. Look at here. Assume that I'm going to configure the router trees interface inside the OSPF, okay? R3 config interface serial 10, okay? Then R3 config if IP OSPF 1 area, for example, the 0001. That's it. With this command, as you can see, we have configured the interface serial 10 of the router tree. Why? Because you know that we go to the interface, we went to the interface serial 10 after that we configured. Then here you can see we are using OSPF process 1 again. OSPF process, okay, ID is 1, and then area, as you can see, is 0001. As you can see here, in the first method, we should go to the OSPF process, router OSPF 1, and then with the network statement, we can identify which interface should enable with which OSPF process, and also, for example, in which area. But in the router tree, as you can see here, first we went to the interface, then we have configured the OSPF for the interface serial 10, okay, and in process 1 and also area 1. Also, in one router, maybe you want to use both of these two methods. For example, in the router 2, let me to show you. Assume that this is the router 2 config. We are configuring router OSPF 1, then R2 config router, okay? We are using network statement 10 1 2 2 quad 0, then area again quad 0. And after that, we can go to the interface. Let me to write here R2 config, okay, R2 config, then interface serial 11 here on the R2 config. If we can configure IP OSPF 1 area, okay, for example 0001. This means that, as you can see here, we have configured the first interface with the traditional method. This is the OSPF network statement or the traditional method, okay, let me to write here. And the second or classic method, maybe you see the classic method in some references, traditional or classic. But the second method, interface specific configuration, means we are configuring with the explicit method. This is the explicit method. If you want, you can configure, you can use both of them in one router. Okay, I will show you the detail of this configuration. After that, let me to say that in some cases, okay, we have a conflict between these two methods. For example, let me to show you here in the router 2, assume that this is the router 2, we are configuring these two commands. Router OSPF 1 network 10.122 quad 0 area 0, and then R2 config router, okay, network, okay, network 10.1.2 look at here, 10.122 quad 0 area 0, then network 10.232 means the serial 11 quad 0 again area 0. As you can see here, we have a conflict. Why? Because we have configured router OSPF 1 network 10.232 means this interface, okay, serial 11 interface quad 0 area quad 0, but this interface should be residing in the area 001. Here we have the correct configuration. But if we have some conflict between the traditional configuration and explicit configuration or interface specific configuration has higher precedence or has higher preferences. Why? Because you have configured on one interface explicitly that this interface is a member of area 1. That's it. Because of that, don't worry about the conflicts. Okay, after that, let me to talk about another situation that maybe you encounter with that in some scenarios. Look at here, let me to show you. Assume that we have this configuration router OSPF1, okay, then for example network 10.1.0.0, then 0.0.255 255, okay, or 10.0.0.10.0.0, okay, 0, then 0.255.255.255 area 0. Okay, after that you have configured network 10.2.3.2 area 0.0.0.1. What does it mean? Let me to talk about it. Look at here, with the network 10.0.0.0 and the wildcard mask of 0.255.255.255 area 0, actually you are configuring all interface starting with 10 in IP address, okay, in the area 0. Okay, this is the first rule. After that, as you can see here, we have the second rule, network 10.2.3.2 quad 0 area 1. Actually here you are configuring this interface as the member of area 1, because here we have configured with more specific, for example here we should use area 1, yes, with more specific a wildcard mask, the next command has higher priority. Actually this interface now is member of the area 1, not area 0, because this is more specific than the previous rule. But the interface serial 10 is the member of the for example area 0. Okay, let me to review the configuration, because we are using this configuration in one scenario here. About the OSPF configuration, you know that in rarely cases we have difference between these two methods, because if you want to configure another feature for OSPF also and you have configured with the IP OSPF process ID area, again you should go to the router OSPF. For example, for many features, again you need the router OSPF. Only for enabling OSPF on the interface you can use one of these two methods. OSPF configuration, router config router OSPF process ID is the first command, and then router config router. Here we should use network interface IP. Here also we have one important notation. The notation is that you should ensure that you have enabled OSPF on correct IP address of the interface, not network ID. Maybe somebody thinks that we should enable OSPF on the network address 10.120/24. No, you are enabling OSPF on the 10.121 the serial 10 IP address, but OSPF should advertise inside the link states the network address, not the interface IP. Okay, this is the configuration of the OSPF. Also, as I mentioned before, if you want, you can go to the router config, then interface name. Here in the router config, if we can configure IP OSPF process ID, okay, and then area ID. Okay, let me to configure these methods in one simple scenario. In the next scenario, we will learn about the configuration of OSPF. Also, we will use this scenario for understanding other features related to the OSPF, such as the router ID, such as the passive interface, or some other things related to the OSPF. This is our OSPF scenario. We want to configure the OSPF in this scenario. As you can see, we have 7 routers, router 1 to router 7, and also we have 3 area, backbone area quad 0. Also, we have 2 non-backbone area 245 and area 367. Here we have serial interfaces, and also here we have some LANs. I'm going to configure the IP addressing and then OSPF. Many of the features of the OSPF will be implemented in this scenario. Okay, starting from the router 1, this is the router 1. Okay, as you can see, in the router 1 we will use the configuration of OSPF with the traditional method. Let me start with this router R1. It is so easy and also interesting. This is the first time we are configuring the OSPF in this class. En then conft, and then host name is the serial 10. That's it. We should configure first to interface serial 10, the IP address of the serial 10, 10.121.255.255.255.0, and then no shutdown. This is the first interface. Let me to configure the next interface. Interface serial 11. The IP address of this interface is 10.2.3, okay, 2. Okay, 10.2.3.2. That's it. Or 10 here, because we are using router 1, 10.1.3.1. As you can see, we are using this rule for addressing 10.x.y.0/24. X is the one side router, Y is the another side router number, and as you can see here, we are using these rules, such as the previous videos. After that, let me to configure the router 2. As you can see, router 2 is one of the ABRs, but router 1 is the, for example, internal router. In the router 2, we have 3 interfaces. Let me to copy one more time the serial 11. Here, we have 3 interfaces. Host name, here we should use host name R1. And here host name is the router 2. Let me to show you. We have 3 interfaces, serial 10, serial 11, serial 12. About the serial 10, the IP address is 10.122.255.255.255.0, no shutdown. About the serial 11, the IP address is 10.242.255.255.255.0, no shutdown. And finally, serial 12's IP address is 10.252, again 255.255.255.0, no shutdown. Okay, let me to copy the configuration of R1. Okay, for the R first we should configure the R4 and R5. Okay, it is okay. For this is for R4. Let me to copy it again here from the router 1. Copy for the router 4. This is for router 4, and this is for router 5. Here we have router 4, and here we have the router 5. Okay, host name is R4. In the router 4, we have 2 interfaces. Serial 10's IP address is 10.244.255.255.255.0, no shutdown. Then we have another interface ETH00. Let me to use duplex full in this interface. Then IP address is 10.101. Okay, 10.101.255.255.255.0, and then no shutdown. Also about the R5, we have the host name of R5. Interface serial 10's IP address is 10.255.255.255.255.0. Okay, and after that, as you can see, about the interface ETH00, we have this IP address 10.5, okay, 0, then 5, 10.5.0.5. That's it. And 255.255.255.0. Okay, now we should configure the router 3 and router 4 and router for example 6 and router 7. The configuration of router 3 is like the configuration of the router 2. Because of that, let me to copy the configuration of router 2 here. And then R2, this is the R3. About the R3, let me to show you. About the R3, we have again host name as R3, interface serial 10, this serial interface. IP address is the 10.133.255.255.255.0, no shutdown. About the serial 11, the IP address is the 10.363, okay, 255.255.255.0, no shutdown. About the serial 2, okay, the IP address is the 10.373. That's it. After that, let me to configure the R6 and R7. For R6 and R7, we can use the configuration of the R4 and R5. Because of that, let me to copy the configuration of these 2 routers. This is the R4 and R5 configuration. First for R6, second for R7. R6 host name is R6. In the R7 host name is R7. In the R6 interface serial 10's IP address, okay, is 10.366, 10.366.255.255.255.0, and ETH00's IP address is 10.606.255.255.255.0. About the R7, the serial 10's IP address is 10.377.255.255.255.0, no shutdown. About the ETH00, the IP address is 10.707 for the IP address of the ETH00, 255.255.255. for example 0. That's it. This is the configuration of the IP addressing. Now we should configure the OSPF. Okay, for the first time, it's a good practice for, that we configure the OSPF on each router in the CLI. But let me to show you how we can configure different routers. In router 1, we should configure the OSPF directly over the interface, because here we want to use explicit method. Because of that, here I am going to use this command IP OSPF. Look at here, IP OSPF 1, then area quad 0, IP OSPF 1 area quad 0. That's it. And then in the serial 11, again I'm going to use IP OSPF 1 area quad 0. That's it. It is so easy. Okay, and also because R1 is one of the internal routers. In the router 2, we should configure on one interface explicit method on the serial 10. Let me to show you IP OSPF 1 area again quad 0. But about the serial 11 and 12, I'm going to use the traditional method. It is not common that we configure one interface with traditional and other interface with explicit method. But for better understanding, let me to configure with this method. Router OSPF 1, now we should use the network command network 10.2.4.2 quad 0. Area is the 245. Let me to use 245. That's it. Then again network 10.2.5.2 quad 0 area 245. That's it. Okay, this is the configuration of OSPF in the router 2. And then in the router 3, again in router 3 we should configure the serial 10 with the explicit method. Let me to show you IP OSPF 1 area for example quad 0, and the serial 11 and serial 12 with the traditional method. Here we should use router OSPF 1. Okay, then network statement network 10.3.6.3 quad 0 area for example 367, and then network for example 10.3.7.3 quad 0 area 367. That's it. This is the configuration of the router 3. Then let me to configure the router 4. In the router 4 we should use the traditional method. Let me to configure router OSPF 1, then for example network statement network 10.2.4.4 quad 0, then area 245, and after that network 10.4.0.4 quad 0. Okay, and after that area 245. Look at here about the ETH00 of the router 4, we should configure this IP address with the 10.4.0.4. Okay, and after that in the router 5, this is the router 5, again we should use the traditional method router OSPF 1. The network statement include the 10.2.5.5 quad 0, then area 247. Okay, after that network, then for example 10.5.0.5 quad 0 area 247. That's it. Let me to configure the router 6 and also router 7. This is the router 6. In the router 6 we should use router OSPF 1, then network. You know that you can use different process ID, but it is recommended to using the same process ID. Network for example 10.3.6.6 quad 0, then area 367, and then network for example 10.6.0.6 quad 0, again area 367, and finally the router 7. This is the router 7. Router OSPF 1, okay, network 10.7.0.7 quad 0 area for example 367, and then network 10.3.7.7 quad 0 area 367. That's it. This is the configuration that we need. Don't forget, in most cases in one enterprise we are using same method, but here only for practice we have used different methods of the configuration. Let me to copy this configuration, and then we can talk about the other features such as the verification command and some other useful tools about the OSPF. This is the CLI of the routers, router 1 to router 7. We can copy the configuration starting from the, for example, router 1. Let me to show you. Okay, starting from the router 1. This is the router 1 configuration. We should copy the configuration carefully. Look at here in the R1, we can copy this configuration and paste it here. As you can see, we don't have any error message. Here, maybe you see for some second or the one error message, OSPF with the severity of 4, okay, no router ID. OSPF process 1 failed to allocate unique router ID and cannot start. Okay, this is because when you are configuring IP OSPF 1 area quad 0, maybe the IP address of this interface wasn't enabled until that time, and because of that maybe you received that OSPF doesn't have router ID. I will talk about the router ID, but don't worry about it because now we have configured OSPF and we have configured IP address on these two interface, and OSPF can easily choose its router ID. Don't worry about this error message. Then the next router is the router 2. Let me to show you the configuration. You know that this is the router 2. Okay, after our configuration we expect to see one neighborship between the router 1 and the router 2. Look at here. This is the configuration of router 2. As you can see, again we have received the same error, but this is working. After some second we expect to see one neighborship between the router 1 and router 2. If everything is working correctly, as you can see, we have the neighborship between router 1 and router 2. I will talk about the detail of this neighborship. Then about the R3, this is the R3. Let me to copy the configuration of R3. Also, after configuration of the R3, we expect to see another neighborship between the router 3 and also the, for example, neighbor router, the router 1. Okay, let me to show you. We should wait some second, because this is the first time we are configuring the IP addressing on the interface. It takes a little time to interface, change the status to the up status, and then OSPF is working. Look at here. As you can see, now we have neighborship between the router 3 and router 1. The next router is the router 4. Let me to copy the router 4. Router 4 is this router. Look at here. When you are configuring router 4, we expect to see neighborship with the router 2. This is the router 4 configuration, and we can paste it here. And then let me to copy the R5 configuration. In both R4 and R5, we expect to see one neighborship. In the R4, after some second, we will have one neighborship. Let me to show you. Yes, now this is our neighborship. Also in the R5, after some second, we will see one neighborship. Okay, we should wait some second. After the R5, we will configure the R6. As you can see, we have neighborship in the R5. This is the configuration of the R6. And finally, the router 7. Okay, I will verify everything from the scratch. But for now, as you can see in the router 6 and the router 7, we expect to see neighborship with the router 3. Look at here. In the router 6, we have neighborship. In the router 7, also we have neighborship. Very good. How we can verify the functionality of the OSPF? Until now, we have configured the OSPF. Now, we want to talk about the verification of the OSPF. You know that we have many commands for verification of other protocols, such as the EIGRP. The first command that we can use to verify the status of the routing protocol that we have in one router is the show IP protocols. And this is not a new command because you have used it when you are configuring one routing protocol in one router. Show IP protocols can show us which IPv4 routing protocol now is enabled on this router. For example, we can use one of these routers, the R1. In the R1, okay, CLI, this is the R1 CLI. Let me to show you. Here we have the R1 CLI. I'm going to use the show IP protocols. Show IP protocols. As you can see, here we have many information about the OSPF from here to here. Routing protocol is OSPF 1. Okay, let me to show you another router, for example, the router 2 about the show IP protocol, because I'm going to compare the results, show IP protocols, and also the for example router 4, the router 4, this is the router 4, show IP, okay, protocols. Now we can compare these three results with each other. In the router 1, router 2 and router 4, we have used show IP protocol. In the router 1, as you can see, routing protocol is the OSPF 1. Also we have the same statement in the router 2, okay, and also in the router 4. After that, about the other lines, I didn't explain because of that. I'm not going to talk about them now. But here you can see routing for network. And then in the router one, you know that we have used the explicit method. Routing on interface configured explicitly. When you see the explicitly keyword, means we have configured the router one with the, for example, interface specific command. Okay, IP OSPF process ID area ID. Okay, and the area is quad 0. We have configured explicitly OSPF on the serial 10 and on the serial 11 of the router 1. This is true, okay? And then in the router 2, you can see that we have two statements. Routing for network. Here you can see the statements about routing for networks. Why? Because we have configured these two interface with the traditional method. Here you can see your comment. But about the serial 10, because we have configured the serial 10 with the interface specific command, you can see routing on interface configured explicitly area quad 0 serial 10. Because of that, you should identify the difference between the show IP protocol result when you are configuring with the traditional method with network command or with the interface specific command. Okay, and in the router 4 we have configured only with the network command. Here you can see routing for network. This is the first difference between the show IP protocols when we are configuring with explicit method or when we are configuring with the network command. The next things that we should know is that here we have some information. For example, in the router 2, as you can see, the gateways means the router that we have receiving link state about them include these 4 routers: router 1, router 3, router 4, and router 5. 1 and 3 in this area, 4 and 5 in the area 247. It's okay. And you know that the administrative distance of the OSPF is 110 for all routes, include internal, external, intra-area, inter-area, everything. Everything's administrative distance is 110. You know that about the EIGRP, we have different administrative distance for internal, external, and summary. But about the OSPF, for all routes, we are using the administrative distance of 110. Okay, because of that, here you can easily understand what is the meaning of gateway. And then in the router 2, okay, this is the router 2. In the router 1, we have only 2 gateway, 2 router that we are receiving the link states from them for router 2 and router 3. In the router 4, we have 2 gateway, router 5 and router 2. This is the router 2, this is the router 5. Okay, you will learn about this, for example, information more than this. After that, let me to talk about the other things in the show IP protocol. In the show IP protocol, in router 4, in the router 1, because this is internal router, we don't have any important notation about the functionality of this router. Only you can see number of areas in this router is 1. That's it, because this is internal router. But in the router 2, as you can see, we have number of areas in this router is 2 in the router 2. Because of that, it is an area border router. Area border router means ABR. You have learned about it before. Now you can see that the iOS considers the role of the router. After that, in the router 4, you can see again we have number of areas in this router is 1. This is the first command that now we can interpret it, we can use it, but you know that about this command we have more information that you will learn about them in the future, for example, videos and in the future courses in this class. The next command that in most cases we are using it for the troubleshooting is the show IP OSPF interfaces or show IP OSPF interface. Here you can use show IP OSPF interface with the name of interface or brief keyword. When you are using the show IP interface without brief, you will receive many information. For example, for one interface, you will receive 1 page of information. In most cases, maybe 90% cases, we don't need to all of this information when we are using show IP OSPF interface. Because of that, it is recommended for example, brief information related to the OSPF and what the interfaces that OSPF enabled on them. You can use the show IP OSPF interface brief. Let me to show you. In the router 4, we have 2 interfaces that we have enabled OSPF on them. Look at here. If you use on the router 4 show IP OSPF without any other keyword, okay, show IP OSPF interface, you can see here, show IP OSPF interface, you can see that we will receive about 2 pages. 1 page, for example, and then second page. As actually for each interface, we are receiving about 1 page of information. And this is not suitable every time. In most cases, we need only to find the, for example, 1 line information about the interfaces that OSPF was enabled over them. Look at here, with the show IP OSPF interface brief, you can easily find that OSPF was enabled on the ETH00 and then serial 10. The process ID is 1. PID means process ID. Let me to write here. PID means the process ID. And also here you can see that area is 245. This is the IP address of 2 interface 10.404/24 for the ETH00 and 10.244/24 for the serial 10. Also here we have other information. You will learn about them in the future videos in this class. Don't worry about them. And also let me to show you the R2. In R2, a show IP OSPF interface brief, okay, can show us that we have 3 interfaces that OSPF was enabled on them. The first interface is serial 10 in the process 1, and then is serial 12 with the process 1, serial 11 with the process 1. As you can see here, we have area 0 on the serial 10 and area 245 on the serial 11 and on the serial 12. Also here you can see the IP addressing of these 3 interfaces. And finally, for example, in the router 1, you can use show IP OSPF interface brief. We have 2 interfaces, serial 1011, that OSPF was enabled on them, on the process 1, on the area 0. And here you can see the IP address of the first interface, serial 10, 10.131/24, serial 11, 10.121/24. That's it. Because of that, in most cases, when we are verifying the status of OSPF, we are using show IP OSPF interface, and in most cases we are using the brief keyword. And then if you want to verify the neighborship table in OSPF, you can use show IP OSPF neighbor. I will talk about the neighborship condition, other detail about the neighborship, okay, in OSPF. Only here we are verifying the OSPF neighborship. You know that we expect to see neighborship between the directly connected routers in OSPF with each other. Look at here. For example, in the router 4, you can use show IP OSPF neighbor. As you can see, we have neighborship with the router 2 here. We can see the IP address of the router 2, 10.242 over, this is local interface serial 10, okay? And here also we have another information, neighbor ID, priority, state, dead time. I will talk about all of them, but for now, serial 10, we have neighborship on serial 10 with the router 2, 10.242. In the router 5, this is the router 5, as you can see here. Let me to show you. EN show IP OSPF neighbor. Look at here, we have neighborship over the serial 10 of the router 5 with the 10.252 the router 2. In the router 2, show IP OSPF neighbor. We have 3 neighbor. The first neighbor over the serial 10, the IP address of the neighbor is 10.121, and here the second neighbor over the serial 11, the neighbor's IP address is 10.244, and the third neighbor is over the serial 12, the IP address of the neighbor is 10.255. That's it. Also in the router 1, show, okay, IP OSPF neighbor. We have a neighborship with the over the serial 10 with the 10.122, the router 2 over the serial 11 with the router 3, 10.133. That's it. This is so important, and we are using the show IP OSPF neighbor in most cases when we are troubleshooting, when we are maintaining the OSPF in one network. Okay, after this command, you know that we have 3 tables in the OSPF: neighborship table, link state database, and routing table. We can use the show IP OSPF database for verifying the database or LSTB. You know that until now we didn't learn about the detail of database. We will learn about the detail of database in this class, but let me to show you the database of R4 and R5. You know that because these 2 routers are residing inside one area, we expect to see same database in these 2 routers. Look at here. This is the a database of router 4. Let me to show you. Show IP OSPF database. Okay, as you can see, this is our database in the router 4. Let me to show you. Okay, OSPF router ID from here to here. You will learn about all of these details in this class. After that, in the router 5, let me to show you the database. Config interface ETH00 duplex is full. Look at here, show IP OSPF database in the router 5. Okay, you can compare these two tables. Look at here, R4, then R5, R4, R5. As you can see, all of the contents related to link ID and advertiser router are same. Only the age, okay, is for example has difference. This is normal. I will talk about the age, you will learn about it. But for the other for information in the database, we have same information. This means that the informations or the topology that we have in the LSTB is same between the router 4 and also the router 5. Between the router 6 and router 7, we have similar information. Look at here. This is the router 6 database, show IP OSPF database in the router 6, and also in the router 7. Let me to show you. This is the router 7 config interface ETH00 duplex is full. Look at here, show IP OSPF database. As you can see, we have similar database between these two routers. Why? Because both of them are residing in the area 367. Okay, but let me to show you the R2. R2 is the ABR. I'm going to show you the database of or LSTB of the R2. We expect to see two parts in the database. The first part of database related to area 0. The second part related to the area 245. Look at here. This is the link state database of the router 2. As you can see here, we have the first part that is include the information about the area 0, and this is the second part that include the information related to the area 245. Why? Because the router 2 is the for example the ABR. Also in the router 3, let me to show you. In the router 3, show IP OSPF database again can show us our information include two parts. The first part for area 0, the second part for the area 367. If you want, you can compare this part area 0 with the R2's area 0. Okay, exactly same. Let me to show you R2 and R3. Look at here. Again, we have similar information about the area 0's information. Okay, in the router 1 is the internal router of the area backbone, show IP OSPF database. We have similar information with the information of router 2 and router 3 about the area 0. Actually, we know that in one area we have same information between the routers, but in different areas we have different information because we have different topology. Okay, and finally, you know that we need to verify the routing table. The routing table can be seen with the show IP route. Okay, you have learned about the show IP route, but if you want to see only the OSPF routes, you can use show IP route OSPF. Okay, don't forget that in OSPF we have many codes. For example, O means intra area routes, means the routes that are residing in our area. Or OIA, okay, means inter area routes. What does it mean? Means that this network is residing outside of our area. Okay, also in OSPF we have OE2, OE1, okay, ON2 and ON1. You have learned about all of these codes in the OSPF, okay, when you have learned about the redistribution. Okay, you will learn about them in this class. After that, let me to show you the routing table of the router 4. For example, this is the routing table of router 4, show IP route OSPF, only the OSPF routes. It is so easy, show IP route OSPF. Look at here. Here we have some routes learned from the OSPF with the code of O, okay, and some other with the code of OIA. Here you can see O means OSPF. OIA means OSPF inter area. Actually, O means OSPF intra area, and OIA means OSPF inter area. Okay, look at here. For example, for the 10120/24, we have learned one OSPF networks. 10120 is this network, 10120. And because this network is residing in another area in compared with the router 4, here we can see OIA. After that, as you can see, we have 10130/24, this network 10.1.3. Again, this has the code of OIA. But about the 10.250/24 in router 4, we have the code of O. About the 10.360/24 and 10.370/24, these two networks, 10.360/24 and 10.370/24, we can see the code of the OIA. About the 10.500/24, this network, we have the code of the O. After that, about the 10.600/24 and 10.700/24, these two networks, again, we have the code of the OIA. It is so easy. Okay, let me to show you the routing table of router 2. In the router 2 show IP route OSPF can show us that we have 10.130/24 with the code of O. 10.1.3 is this network because router 2 is a router as a member of 2 area. The 10.130, this network is an internal network, and because of that, as you can see here, we have O as the code of OSPF. For the 10.360/24 and 10.370/24, these two networks, okay, this network and this network, we can see that we have the OIA code. But about the 10.40/24 and 10.50/24, both of them, these two networks, okay, the 10.450 and 10.400/24 and 10.500/24, these two networks, both of them are internal. Actually, we can say that all of the networks inside the area 0 and inside the area 245 are intra-area routes for the router 2. And here you can see 10.600/24 and 10.700/24 with the code of the OIA. Actually, until now, we have learned about these commands: show IP protocols, show IP OSPF interface, and also show IP OSPF interface brief, show IP OSPF neighbor for neighborship table, show IP OSPF database for LSTB, and finally show IP route OSPF for the verification of the routing table. Now let me to talk about the routing table with more detail. This is the routing table of router 4, show IP route OSPF. Okay, as you can see, we have for example one pass to the 10.120/24. 10.120 is a pass that has is residing in another area. Because of that, here we can see the code of OIA, means OSPF intra area. Then here in the bracket we can see the first number is 110. You know that this is the administrative distance, okay, and the administrative distance of OSPF is 110. Also, after the administrative distance, we have the metric value, and the metric is 128. Let me to give you a little more information about the metric, but you know that about the metric we will learn more than this in this class. Here we are only reviewing the concept of metric now. Look at here. In the OSPF, metric is calculated based on the bandwidth of the interfaces. For example, for each interface, okay, for each interface in OSPF, we have one cost value, and this cost value is using for the calculating the best path to for example one destination network. Okay, here the cost of each interface, or OSPF cost of each interface, is equal to the 10 to the power of 8, okay, divided on the interface bandwidth. For example, if the interface bandwidth is for example at 10 megabit per second, 10 megabit per second means Ethernet. Okay, here the cost of interface is equal to the 10 to the power of 8, okay, divided 10 to the power of 7, because 10 megabit means 10 multiply 10 to the power of 6, or 10 million. Okay, here we have the cost of, as you can see, the cost of 10. It is so easy. Okay, after that, about the cost of for example fast Ethernet, let me write here, assume that we have one interface bandwidth equal to 100 megabit per second. 100 megabit per second means the fast Ethernet. The cost of fast Ethernet equal 10 to the power of 8 divided on 10 to the power of 8 equal to the 1. That's it. Okay, about the serial interface, let me to calculate. This is the interface bandwidth. About the serial interface, you know that we have the bandwidth of 1544 kilo. Okay, if you use this formula, you can find that the cost is equal to the 10 to the power of 8 divided on the 1544 kilo. You can use one calculator. Look at here, this is our calculator. 10 to the power of 8, okay, divided on 1544 kilo. 1, 2, 3. As you can see, this is resulted to the 64.76. We should round it down and the result will be 64. Because of that, the cost of serial interface in OSPF by default is 64. You will learn more than this about the OSPF cost and also OSPF metric calculation. For example, if R1 has with one serial interface connected to the router 2 and router 2 connected with one, for example, fast Ethernet interface to net A, you can calculate the R1 cost to net A equals 64 because serial 10 has cost of 64. Then a plus, okay, 1. Fast Ethernet has cost of 1 to the net A, and the final metric or total cost, the metric is the 65. Actually, in OSPF, the metric is equal to the total cost, and total cost, as you can see here, is 64 plus 1 equal to the 65. Now let me to show you the cost in the show IP OSPF interface brief. Look at here, this is the R4. If you want, you can use show IP OSPF interface brief. Look at here, ETH00, because this is the Ethernet interface, has cost of 10, and now you can easily understand the meaning of cost. After that, the serial 10 has cost of 64. Also, if you want, you can use show IP OSPF interface serial 10. Okay, here you can see the serial 10's cost is 64. Show IP OSPF ETH00, the cost of for example, this interface, okay, interface ETH00 is 10, as you can see. Also in the router 5, let me to show you, in the router 5, if you use show IP OSPF interface brief, you can see the cost of Ethernet 00 is 10, the cost of serial 10 is 64. It is okay. And then in the router 2, let me to show you the cost of interfaces in the router 2. Show IP OSPF for example, in interface brief can show us that we have 3 interfaces. Serial 10's cost is 64, serial 11's cost is 64, and serial 12's cost is 64. You can change this cost, but for now let me to use the default cost for analyzing the routing table. In the router 4, okay, let me to show you again the routing table. Show IP route OSPF can show us that we have this cost. For example, for reaching to the 10120/24, 10120/24 is this network. Okay, we have 2 serial links, serial 1, serial 2. Here, because of that, the cost of 2 serial is equal 64 plus 64 equal to 128. It is okay. About the 10130/24, this network, we have 3 serial link, 1 serial link, another serial link, another serial link. We should, for example, we should add the cost of serial 10 of router 4 to the serial 10 of the router 2 to the serial 11 of the router 1. Actually, for each link, we are counting one time the serial interface, okay? 64 plus 64 plus 64, 192 outgoing interface to this link. And then 10250/24, 10250/24 is this link, okay? The link between router 2 and router 5. The cost of R4 to this network is 128, as you can see. 64 plus 64 equal to 128. Also, 10360/24, this network, okay, has cost of 256. Why? 64 plus 64 plus 64 plus 64. 4 multiplies 64 equal to 256. About the 10370, this network, we have the same cost. Okay. About the 10500/24, okay, this network 10500/24 cost is equal 64 plus 64 plus 10. 64 plus 64 equal 128 plus 10, 138. That's it. Then about the 10600/24, this network cost is 64 plus 64 plus 64 plus 64 plus 10. 256 plus 10 is equal 256, 266, and finally here you can see for the 10700/24 we have the same cost. Also here you can see the next stops. For example, in R4, for reaching all destination, we are using the router 2 as the next stop, and this is the amount of time that we have learned these routes from other routers. As you can see here, if you experience some change, you will see that here we have for example the new update. For example, let me to shut down one of the interfaces in the router 6. I'm going to shut down the ETH00 conf.d interface ETH00 shutdown. Okay, and then in the router 4, now you will see that we don't have a pass to this 10600/24. Look at here, we don't have this pass. But in the router 6, okay, if you enable this network again, no shutdown, in the router 1, in the router 4 again, you will see that we have this pass, okay, in the routing table after some second, but the time now is reset to the 0. It is obvious. Also, if you want to verify the OSPF internal function, you can use show IP OSPF without any other, for example, options. Show IP OSPF. I'm going to show you one important notation. Look at here. For example, in the router 5, okay, we can use show IP OSPF. About the show IP OSPF, we will learn more than this in this class, but now only I'm going to show you the show IP OSPF itself. Routing process OSPF1 with ID, for example, this ID. I will talk about the router ID, but until now here we have many information, as you can see, and some of them can be explained in this class. But here you can see information about the area 245. Number of interfaces in this area in the router 5 is 2, and some other useful information. Okay, let me to show you one interesting things here. As you can see, the last SPF calculation, okay, or SPF algorithm last executed on 1 hour 15 minutes before. Okay, and also we have executed SPF 2 times. That's it. If you disable the ETH00 of the router 6, let me to disable it again with the shutdown command. Okay, and again with the no shutdown, we are enabling the interface ETH00 of the router 6. In the router 5, as you can see now with the next show command, we don't have any change related to the last time that SPF algorithm executed, and also the number of SPF algorithm, for example, executed, for example, 2 times. We don't see any change. Why? Because when you are removing one link, okay, without topological information, you don't need to use SPF algorithm. And this is one of the benefits of the area and area structure. Now assume that we are shutting down the router 4 interface. Look at here. In the router 4, I am going to use interface ETH00 shutdown. Okay, we shut it down this interface. Okay, in the router 5, let me to show you what is happening now. In the show IP OSPF, you can see SPF algorithm executed. Why? Because here we have a topology change, and we should calculate the new shortest path tree. Also, let me to enable it again, R5. In the router 4, again, let me to enabling this interface again. And after that, in R5, after some second, you can see the next SPF algorithm executed. What does it mean? It means that if you don't have area structure in one network, for each change, removing or adding one link or subnet or changing metrics or some other things, okay, you need to execute one time SPF, and this is so a CPU intensive process. Because of that, as you can see here now, we are experiencing one of the other benefits of the area structure beside of the CPU and memory usage, okay, and that is the for example, lower number of the SPF execution. And also this means that the SPF, okay, that is a CPU intensive process, is not needed to be run for each change in all over the network. Only for the change inside of our area we need to execute the SPF algorithm. The next feature that we can talk about that in this scenario is the router ID. You know that in OSPF we have one identifier for each router, and that identifier is the router ID. Router ID is like the EIGRP router ID, but with more importance. In OSPF, the router ID is so important because when one router creates the topology, actually in that topology for identifying each router uniquely, we are using the router ID. Because of that, router ID is one of the important concepts in the OSPF. Okay, how we can configure the router ID? Let me to say that to talk about the router ID or OSPF router ID. Router ID is a 32-bit identifier. We are writing the router ID like the IP address, but this is not IP address, okay? Like the EIGRP, okay? But the OSPF router ID is different with the EIGRP router ID. You can configure the router ID with this command, manual configuration of the router ID. How we can configure the router ID? It is so easy. Router config router means in the OSPF you can configure router ID A.B.C.D. Don't forget, if the router ID was selected before, okay, and you have neighborship with other routers, maybe after configuring this command you need to clear OSPF process. Why? Because we need to tear down the neighborship with other routers with the old router ID, and then we can establish new neighborship with the new router ID. Clear IP OSPF process is a command that you should use it for clearing. Means that for example, shutting down the neighborship, and after that enabling again the neighborship, and after that you will have the new router ID. If you want to verify the router ID, one of the commands that you can use is the show IP protocols. I will show you. Okay, show IP protocols. Also, it is not needed to configuring the router ID. It is not mandatory. If you don't configure the router ID can be selected from the highest IP address of the any loopback interface. Highest IP address of the loopback interfaces, but the loopback should be up. Okay, and if we don't have loopback interface in one router, the OSPF is using the highest IP address of the non-loopback interface. Why the loopback interface has priority? Because you know that loopback interface always is up, okay, and the only way that loopback interface is for example go to down state is shutdown command. Okay, because of that it is better to using the loopback IP address for the router ID, because we can ensure that this router ID is same always. Okay, but about the other interfaces, non-loopback interfaces, such as the serial or fast Ethernet interface, this is possible that, for example, interface a cable disconnected, interface itself corrupted, and also some other things. Because of that, it's better to using the loopback in compare with the non-loopback IP address. But in about the best practice in OSPF, it is recommended to configuring router ID ourselves. Why? Because router ID is so important in the OSPF. For example, when you are using multiple show commands you encounter with the router ID, it is better to configure router ID with one, for example, naming rules or name policy in our enterprise. Okay, and here let me to show you the router ID of, for example, router 4. In the router 4, the router ID, now we expect to see the router ID as the highest IP address, because here we don't have loopback. The highest IP address of the router 4 is 10.4, okay, 04, the IP address of the ETH00. In the show IP interface brief, you can see that this is the highest IP address. Show IP protocols also can show us that the router ID is 10.4.04. And in the router 2, okay, in the router 2, if you use show IP OSPF neighbor, you can see that one neighbor ID, okay, one of the neighbor ID is 10.4.04. It is not so easy to understand that the 10.4.04 is the router 4. Why? Because router 2 connected to the 10.2.4.4, not 10.4.04, because this is neighbor ID, this is neighbor IP. Okay, neighbor ID means router ID of the neighbor, and this is the address, means IP address of the neighbor. Because of that, it is recommended to configuring the router ID in the OSPF. Let me to configure the router ID of router 4. The conft, okay, router OSPF1. Look at here. I'm going to configure router ID, for example, quad 4. As you can see here, we are receiving one message. The router ID doesn't change. Why? Because we have neighborship with router 2. If you want to change the router ID, you should reload the router or using clear IP OSPF process command to, for example, changing the router ID. Look at here in the do show IP protocol. As you can see now, we have the previous router ID. Now, let me to clear the neighborship. Do clear IP OSPF, for example, process. That's it. Reset all OSPF process. Yes, that's it. And now the router ID should change. Look at here. As you can see, the neighborship goes to down state, and then again the neighborship now is enabled again in the show IP protocol. Okay, we can see that the router ID is quad 4. Let me to change the router ID of router 5 also. Conf t. Okay, conf t router OSPF 1, router ID is quad 5, and then do clear IP OSPF, okay, process. That's it. And then in the router 2, let me to change it. Conf t router OSPF 1, router ID quad 2. Here we should use again clear IP OSPF process. After that, the router 1, this is the router 1. Here en again conf t router OSPF 1, router ID quad 1, then a clear, okay, clear IP OSPF process. Now let me to show you the result of this configuration. In the router 2, when you are using show IP OSPF neighbor, you see that we have 3 neighbors. The first neighbor is router 1. Neighbor ID means router ID of the neighbor. This is neighbor ID, this is neighbor IP, as you can see. Neighbor ID is quad 1 and the IP of neighbor is 10121. The next neighbor is quad 4 and the address of this neighbor is 10244. The next neighbor is quad 5 and the address of this neighbor is 10255. As you can see, it is easier to understand the, for example, different tables in the OSPF with a easier or simpler router ID. Also about the database in future, you will learn that with these router IDs we can more easier analyze the database or LSTB. Let me to change the router ID in the router 3. Here en conf t router OSPF. We have changed in the router 3. Okay, let me to show you do show IP protocol. No, we should change the router ID in the router 3. Router OSPF 1. Okay, router OSPF 1, router ID is the quad 3, then do clear IP OSPF process. After that, in the router 6, okay, this is the router 6, en conf t router OSPF 1, router ID is quad 6, and then do clear IP OSPF process. And finally, in the router 7, because we need to use better names, router OSPF 1, router ID quad 7, and after that do clear IP OSPF process. Okay, that's it. Now we have these router IDs in our network. For example, let me to show you in the router 3, you can use show IP OSPF neighbor. The router ID of the router 1 is quad 1, the router ID of the router 6 is quad 6, and the router ID of the router 7 is quad 7. And this is recommended to configuring the router IDs in different routers in the OSPF. You know that in OSPF we are using some packets for the neighborship. Let me to say that in OSPF we are using again hello packets, OSPF hello packets for the neighborship. You will learn about these packets in the next video and also about the neighborship condition. But let me to say that when you are sending the hellos, you want to find the neighbors. You want to discover the neighbors. After that, we can exchange the information with the neighbors, for example, link states. Okay. But as you know, when we are enabling the OSPF on one interface, on that interface, we are sending the hellos. OSPF hellos. In some interfaces like the EIGRP, we don't need to send hello. Why? Because here we don't have any new neighbor. For example, R4 is sending in some intervals the hellos of the OSPF over the ETH00. But as you can see here, we don't have any neighbor. We don't have any router. Sending these hellos in interval result to the consuming the bandwidth of this link. And also here we have some security risk because some other systems can receive these hellos and can use them. Because of that, it is better to stop the sending hello on this interface and also accepting hello on this interface. You know that In EIGRP, we have a concept, we call it passive interface. Exactly same concept is available in the OSPF. It is recommended to configuring the interfaces that we have OSPF on them, but we don't have any neighbor on those interfaces as the passive interfaces. And also the configuration also is same. Look at here in the router OSPF. Let me first configure the previous command here, router config router. The previous command was router id a.b.c.d, and here let me to say that you can configure with two methods, one interface as the passive interface, okay, then interface name, this is the first method, or if you want you can configure all interfaces as passive, okay, means with the passive interface, okay, default, and some other interfaces as non-passive. Exactly the same concept and same configuration with the EI such as the EIGRP passive interface with the, or for example, no passive interface. Then the name of that interface, no passive interface, interface name. So easy. For example, let me to show you in the router 4, if you want, you can capture the ETH00. Here in the capture, you will see that here we have the OSPF hellos in for example, 10-second interval. You will learn about the interval more than this in future, but look at here. We are sending hellos of the OSPF from the router 4 10404 to the reserve multicast address of the OSPF 224005. As you can see, we are sending these hellos in the 10 interval, 4, 14, 24, 34, 44, and so on. Okay, let me to stop sending hellos. Here, as you can see, we are sending OSPF hellos. Okay, OSPF directly sending over the IP with the protocol number of 89. Here you can see the OSPF protocol number is 89, the EIGRP protocol number is 88. Okay, let me to stop sending these hellos with configuration of the passive interface in the router 4. With the passive interface, name of that interface, conf router OSPF1 passive interface, okay, ETH00. Okay, now on this interface we will not see any new hello. As you can see, the hello doesn't send and now in this interface, because this interface now is one of the passive interface. Do show IP protocols also, such as the EIGRP can show us that we have passive interface as the ETH00. Also, if you want, you can see show IP OSPF interface, okay, with ETH00. Here, as you can see, we don't send hellos. No hello. Why? Because this is passive interface. Okay, and also we don't accept hello on this interface. But if you check the show IP OSPF interface serial 10, you can see that we are sending hello, for example, in 5 seconds later, and the next hello is sending in 9 seconds later, and so on. Because of that, we have configured the R4 ETH00 as the passive with the first method. If you want, you can configure R5's interface also. This is the R5 passive interface ETH00. And in the router 6 and router 7, let me to use the next method, passive interface default. Okay, now all interfaces are passive. Then no passive interface serial 10. The serial 10 is not passive because we are sending hello on that interface, and also we are accepting hello on that interface. Show IP protocols can show us that here we have all of these interfaces as the passive interface. Only one interface is the, for example, the interface serial 10 is not non-passive. As you can see here, we don't have serial 10. Also in the router 7, let me to configure passive interface default, no passive interface serial 10. Again, we have a neighborship. So easy. Okay, in the router 4, let me to check the routing table again. Show IP route OSPF, everything is okay. Ping, for example, 10. Let me to test connectivity with some places. 10.6.0. For example, 6. This is the ETH00 after router 6. Ping 10.7.0.7. The ETH00 after router 7. Ping 10.5.0.5. The ETH00 after router 5. Actually, we are using the OSPF here for completing the routing tables. And now we have learned about the passive interface. You will learn about the detail of the OSPF neighborship in the next video. Alright, in this video we have learned about the OSPF basic configuration. We have configured one scenario in multi-area. Also, we have learned about some topics such as the router ID, such as the passive interface in the OSPF. And also we have learned about the commands of the verification of the OSPF, such as the show IP protocols, show IP OSPF interface, show IP OSPF neighbor, show IP OSPF database, and also show IP root OSPF. Also, we have learned about the cost of the OSPF. Okay, we will learn step by step about the OSPF. Until now, we have, for example, learn many things about the OSPF, but we should gather more than this information about the OSPF function. For example, in the next video, we will talk about the neighborship, okay? How the neighborship is establishing between two routers in the OSPF, and also what are the neighborship requirements of the OSPF. Step by step, we should learn about them, and this is the first step about the detail of the OSPF. Then we will talk about the, for example, link state database, the content of the link state database, different LSA types, and finally you will see that after, for example, 6 or 7 or maybe less, maybe more video, you have a good knowledge, a solid knowledge related to the OSPF. But for now, it is your time. You need to review the concepts and also the configuration of this video. And also, you need to configure this scenario from the scratch, step by step, okay? You have enough time for learning. Don't worry about the time. After ensuring that you have learned about everything in this video, please come with me to the next video. I will talk about the OSPF neighborship.